Hello friends, welcome to another video. And this video we are going to discuss about the automotive bootloader again. In the last time we have seen the overall concept of the bootloader, but this time we are going to discuss more about it. So as the title said, it is automotive bootloader. We can say the part two, and there we will study the bootloader in terms of more about the diagnostic as well, how the different request will be served. Let's say, for example, download service 34, 36 for transfer data, and 37 for the transfer exits. So let's jump into the next slide. So this slide indicate that what are the different sequence which is being used to program the ECU, and here you can see the sequence. The first and at the most, let's say, the is the programming session request. Okay, so once we do a power on, let's say we are in default session, so then we need to enter into the programming session. So to at the first step, so then we will go do the other steps. So then the next step is basically the first step is programming session request, where we will send the 1002 request. Okay, definitely you need to understand the concept of the sending UDS request and getting the UDS response. Okay, that is that I already mentioned in my previous video. If you do not know, I will let's say add a link for that video. Okay, the next step is basically the security access to unlock the issue with using the service 27. Okay, so 27 service is being used. Then we will have the OEM specific redata by identifier, or it could be the other stuff which is specified by the OEM. So there it will vary depend on different OEMs. Then erase request, definitely before we do a programming we need to erase that complete sector. Okay, so if we are using the multiple blocks, then basically we need to erase the multiple blocks as well. Then definitely we will do a programming request, and in the programming request the first step would be to, yeah, basically send the download request followed by the transfer data and yeah, transfer exit. So basically first step is 34, then 36, and then 37. Then yeah, we will do the application validation. Basically it is very important to validate the application. Let's say if we are doing the programming, then it is very important. If we do not do a validation, then it may result to downloading the corrupted application and jumping to the corrupted application, which may lead to an corruption of the issue, and we may not be able to revert back itself. So this step is very important because it is very crucial from the security point of view as well. So there also we have a different validation kind of, let's say, signature validation and other stuffs which will be involved. So it again, it depends on the OEM specification. And then finally, if we are validating this application, then once we confirm that everything is okay, then we will perform the ECU reset. So yeah, what are there are different kind of format. We will not go into depth in this uh, yeah area, but yeah, there is a one format is VBF format, second format is bin, third format is Intel hex. Okay, and yeah, the next format is Motorola S format. So yeah, you can visit this site, and there I have described what is the sequence and how it is being stored into the memory. Okay, the yeah, so these are the standard hex format. Also I have given the, so it is having the, you can follow and read this detail, then you will get more information. Then yeah, I think in the previous lecture also we have seen more about the memory layouts. Okay, um, how the flash memory and the RAM is being organized. So if we see the ECU, in the ECU we have the yeah, program memory or the flash memory, and then we have the RAM as well. Okay, so here yeah, let's say protected boot sector, and then erasable and programmable things. Okay, so it is being described over here. And then yeah, in the last section also we have shown that the PBL, in case of, let's say, flash booter where we will not use the RAM. So in this case, let's say we have a primary bootloader which will basically program the other part of the flash memory, which will be used from the primary bootloader itself. So primary bootloader having the one section and the other section will have the application code. So in the next, yeah, this slide we can see the concept of the two-level bootloader where we have the flash memory and then we have the RAM as well. So what we will do is, basically at the end, we have the primary bootloader. The primary bootloader will be used to load the secondary bootloader, and secondary bootloader will go into the RAM area, and then it will control the transfer to the RAM or the secondary bootloader. So now secondary bootloader will have the capability also to program the this application area as well. So it will also have the capability of erase and download as well. So basically the primary bootloader will not having the capability to directly download into the application area, so it will just copy the secondary bootloader into the RAM, and the secondary bootloader will have this capability. So you can say this primary bootloader, yeah, secondary bootloader having the primary bootloader plus additional stuff which is capable of erasing and downloading. So this is the general concept for the SPL. Then let's talk about the general negative response code. Okay, so it is very important when we deal with the basically bootloader. We also need to know what are the different negative response code we need to support here. Okay, so there are two, according to the specification, there are two types basically. The one category which will fall under the code hacks, it's a 1 to 7F, which is mainly related to the communication related NRCs, and the other part is basically 802FF. So as we are using the 1 byte, okay, so maximum 0 to FF, these are the maximum possibility of negative response code. Yeah, so these are the maximum possibility, and it is, you just keep just remember that the negative response code will be sent from the ECU to the tester. Yeah. So then this is the slide where I just wanted to give a highlight. There will be a tool, okay, which will facilitate the download. Okay, so whenever you are using, let's say, so there will be a specific tool which we are using, which you will be able to update the application images or the bootloader images, and then at the end you will just press the download button, and then it will basically allow you to program the issue. Okay, yeah, as we are talking about the negative response code in the previous slide. So here, the negative response code is being given, and what is the meaning of that negative response code is also being given. So first one is the general reject, where that value is 10, hex 10. Then service not supported, which is 11. Then function not supported, 12. Incorrect message length or invalid format, which is 13. Condition not correct, 22. Programming, let's say the, yeah, request sequence, basically it is basically a sequence error, which is 24. Then request out of range, which is 31. Security access, 33. General programming failure, 72. And pending response, basically, which is 78. So these are the most popular NRC which is being used while uh, dealing with the bootloader. Yes, so here we have given the little more detail about it. So request correctly received but pending response. So you can say that should be sent when the request is correctly formulated, but server has not set yet completed the required actions. So in this case, pending response needs to be sent. Yeah. The next one is gender reject. Gender reject basically, yeah, if you can see, read the description that says should only be used if none of the NRC defined in the UDS standard meet the requirement of the implementation. So if you do not find the suitable NRC, then you will send the NRC 10. Service not supported. So basically you have the service ID, and if the service ID uh, do not fall under the complete SID table, or maybe it do not have that SID, or that SID is not supported, then you will send the 11 hex 11. Then if the SID is correct but subfunction is not correct, then you will send the subfunction not supported, that is NRC 12. Then incorrect method length or the format. So basically, if you are saying the length is not correct, or the, yeah, if let's say if you are saying the 07 and then you are sending 3 byte, then it is invalid message length, right? Because that it is not correct length. So in that case you will send 3, or maybe it is possible that you need to hold the 2 byte or 3 byte, but you are sending only 1 byte or so. It is, if the format is not correct, then also basically it is invalid format, then also this will be sent. Condition not correct. So one of the popular NRC, if the preconditions which is required to be sent out, the, let's say the speed, or it could be any other condition which is required to be met to send that request. Let's say if the service is supported in particular section, but if it is not there, or there may be some limit, um, yeah, ignition is required, or maybe engine speed, that's the vehicle speed is below certain range, then if it is not met, then this NRC will be sent. Sequence error is basically another popular. So there are multiple requests which you need to send in a sequence. For example, 34, 36, 37, and even 27, 20, 2701, 2702, which is for a security access. If you are not following this sequence, then if you're directly sending, let's say 36 or maybe 2702, then it is basically wrong sequence, and then you will get this 24 as an NRC. Request out of range. So if you wanted to erase a particular area which is not available, let's say if there is not outside the range of valid address, then you will get this request out of range error. Security access denial. So you need to unlock, let's say if you need to perform certain operation, and for that if security is required to be unlocked, but if you have not unlocked the security and if you're trying to do this, then you will get the security access denial. So then if you send the request 27 and you unlock the issue, and then if you try to send the request again, then it will get through. Yeah. So basically, and then general programming failure. So yeah, so you will, if you are basically, if the programming is, yeah, if you are sending, let's say if you're trying to directly program the issue without erasing, then you will observe this error as well. Yeah, it is important to know the format of the negative response code as well. Okay, so the format of the negative response code is basically of 3 byte. You can see that the first is response SID. Okay, then yeah, the parameter 1 and then parameter 2. So for example here, yeah, so you can see that it is I think somewhere not correct, but yeah, you can see the first one is the 7F. Then whatever the SID you are sending, that SID will come, and then specific response code which is let's say the out of range or whatever we discussed, that will be sent. So these are the, basically these are the 3 byte which is being used to understand the negative response code. Yeah, and definitely you need to know this, and based on this you can interpret what exactly is wrong, and you can correct the request. So it is very much important to understand the what is the negative response code and what action you need to perform to avoid this error. So yeah, the next slide is for the suppressed positive response. So definitely, yeah, for a certain time, if you are sending certain requests, let's say ECU reset or any other request, it we may also send with suppressed positive response. So what is mean by suppressed positive response? So here we can see that there are 0 to 7 bits. Basically, there are 8 bits, and the sub function byte basically bit number 7. If the bit number 7 is 1, which will be reserved for the basically suppressed positive response. Yeah. So if it is 1, then it will understand that the positive response is not required to be sent. Only in case of error, the negative response will be sent. So if the operation is successful, response will not be sent. But if it is unsuccessful, then you will observe the negative response code which we have seen already. So let's talk about the request, programming session request. In this programming session request, you can see the 1002 is the requested byte, okay, um, which will be sent for the programming response. Definitely, if you are sending from a Kenoi, then you need to give the 02 basically length as an input. Yeah, basically otherwise you can send the 1002, then yeah, you will get a response. In the response, you definitely you can see the response byte will be the 5002. 50 is basically 10 plus hex 40 to indicate the positive response. We already discussed about this in our last lecture, so I will not repeat. So basically you need to add 40, or you need to, yeah, make the specific bit 1, then this will be respected as a positive response. Then you will get additional 4 byte generally in the response, which will be reserved for the P2 and P2 star timing. So yeah, this is the basically 10, and this is the, if you check this, I think it will be 500 milliseconds. So generally these are the timings which will be followed, but yeah, you can convert this into decimal value, then you will get the actual value. Next one is negative response code for this operation, basically sub function. So if we see that 1002, yeah, definitely if you are sending, there is a possibility that you will send another sub function which is not supported. Then you will get the, as if you are giving 1008 something like that, then it is sub function not supported. If you do some mistake in length, then also 13 is also possible. And if you are not meeting the specific criteria before entering the programming session, then you will get 22 as well. Second operation, or the second request which we are talking about, is ECU reset. Definitely ECU reset is the service ID for that is 11. Sub function here we are talking about is hard reset, that's why we use 01. So 1101 is the requested byte for the ECU request. And then yeah, definitely we can, there are possibility that we will also get 33, yeah, and other NRC code we already discussed. So I think there is also possibility that we will send a ECU reset request with sub function not supported, which is, let's say, 1009 or something like that, which is not there. So 11, sorry, 1109. Then there is a possibility we do some mistake in length, that's why 13, and condition not correct. So there are specific precondition is to be required to be met. If it is not met, then 22 also is possible. And for this, definitely we require to unlock the issue. If it is not unlocked, then 33 is also possible. Security access service. So security access service is basically very much important, because because of this we will prevent uh, the unauthorized access to the issue, because it will we need to unlock the ECU. We need to have a valid authorization, then it will unlock the ECU. So generally the mechanism of seed and key will be used for this purpose, depending on the which kind of security algorithm will use. That is also one important criteria for this. But yeah, this is the one of the very much important service when we deal with the bootloader. Yeah, so definitely we need to unlock the ECU before performing the programming or erase request, then it is needed. As I talk 2701, so 2701 is the request we need to send for the security access, and then we will get a response which is, as I said again, 27 plus 40, which is 67, and then definitely 01. Then we will get a seed value. It may depend that we can get a 3 byte or 4 byte of seed value depending on our specification and algorithm which is being used. Okay, so you can see that the security seed will be then used in the vehicle manufacturer specific algorithm. So this will be the input to get the security key basically. So yeah, this is the detail you can read out through this information. Okay, yeah, let's go to the next one. So the next one is 2702, where we will use those seed value to get the key. So we are sending the 2702 with the 4 byte of the seed which we received, and yeah, sorry. So here, based on that, basically we will calculate the key, and we will send that key, and in the previous one, sorry. So and then basically we will get the positive response. So basically we are unlocking the, we already unlocked the security access. Yeah. Next one is the, yeah, what are the different sub, let's say NRC code which will be supported for the this service. So 12, 13, 22, 24, and 31, which will be used for this purpose. Yeah, there is a specific negative response code also which will be supported for this service, which is 34, sorry 35, 36, and 37. So if we are trying to unlock the ECU with invalid key, then we will get a 35 as an response. And yeah, basically if we try again and again with the invalid key, as we have in, if we observe in our mobile, we have a maximum attempt, right? So first time we do a wrong pattern, then it will say that yeah, you are not allowed to unlock, you cannot unlock. Then if you do a 3 time retry, okay, then till that time you will get invalid key, 35 is the response. But if we try next to that, let's say maximum is 3, and then if you're trying fourth time, then basically you will get a 36 because you already reached the maximum limit. That's why it will give a negative, yeah, another negative response code. At the same time, yeah, it will start, yeah, the timer. So after that also, if you are trying, then you will get 37 because the negative. So during this time, let's say after that, let's say if the timer of 2 seconds is being started, then if you are again retrying to unlock the ECU, then you will get this error because you are not allowed to again try till this time being expired. So if you will try after this time, then yeah, you will be able to, yeah, if with the valid key you will be able to unlock. But yeah, without, if you are not trying to with valid key, then again you will get 35. So these are the important NRC which is being required to be implemented for the service 37. So we will end this session, and in the next session we will cover the next part of the services.